Okay, so let's do this next one. What variable here, and remember, there's no wrong answer to this. What variable do you want to cancel?
2.
What variable? Why is x the most logical? They're already 2's, right? So if I multiply one of these by a negative, that would make them opposite, right?
Oh, no, the other one's already opposite.
Well, if I want to cancel these, those aren't opposites. Okay, so the 4 and 2 are opposites, but they're not opposite signs, but they're not the opposite numbers, right? So I'm going to multiply the bottom one by a negative. So that turns into negative 2x. This turns into a positive 2y and a positive 8, right? I just multiplied everything by a negative 1. I multiply anything I want to. So negative 1 is my choice here to multiply. And that's just going to effectively change the signs for each term in the equation. Okay? We'll go through this and do this another way if that was confusing to you. But now, what's going to happen with those two? They cancel when I add straight down, right? How many y's will you get? 6 y's. And what's 22 plus 8? 30. So y is going to be 5. Bless you. So y is 5. Okay? I'll plug that back into, I'm going to go in equation number 1 here. So if I go 2x plus 4 times 5 equals 22, that's 2x plus 20 equals 22, right?
Wait, hold on. You can plug it in either one, right?
Yeah, you can go either one. So 2x will equal 2. And like Ollie said, x should be 1, right? So my answer is 1, comma 5. Okay? Now, if you're a person that said you wanted to cancel y's, so start off as 2x plus 4y equals 22, and this was 2x minus 2y equals negative 8, what would I have to multiply the bottom one by so that I could cancel y's? 2. If I multiply the bottom one by 2, that's going to turn it into 4x minus 4y equals negative 16, right? The top one doesn't change. I'm going to add straight down. How many x's do you get? 6. What happens to your y's? Cancel. And then what am I left with here? What's 22 minus 16?
No, what am I saying?
6. So then x would be what? X would be 1, which is the same one that we found up there, right? Now if I plug back into that equation, I'm going to have 2 times 1, which is just 2, plus 4y equals 22, right? Subtract 2, I get 4y equals 20. What's y going to be?
5.
Still 5. Same numbers right there, right? We still get the answer 1, comma 5. So there's really, because I think multiplying by negative 1, you guys are going to do that as quick as multiplying by 2, right? So when we ask what variable do you want to cancel, x's or y's, in this case I don't think, just because of how easy those two multiplications are, I don't think there's a wrong answer to that. Okay? Either route you want to go. But understand, it doesn't matter. You might have different work than your neighbor, but you both get the same answer, 1, comma 5. All right? Does that make sense? And depending on what you saw, like if I want to cancel y's, then that's going to solve for x first. If I cancel y's, that's going to solve for y first. So that's another thing to think about if you're comparing your work with somebody else's. What about those two? Okay, so the y's cancel. Now, can I work to cancel x's? Yeah, but we're going to multiply that bottom equation by if I wanted to cancel x's. Negative 3, right? Because that'll give me a negative 3x. Now, that would be fine. We'll get to the right answer, but that's unnecessary work, right? And we don't like to do work to begin. Inherently, humans are lazy, right? Yeah. So we don't want to do work anyways. So let's make sure that we put the thought into choosing the option that requires minimal amount of effort. So the y's are going to go away. How many x's do you left with? 4 x's. And negative 15 plus 19 would be 4, right? So x is 1 again. Now, which equation do you want to plug that back into? I heard top first. So what's 3 times 1? 3 plus 2y equals negative 15. Now what do I do?
Subtract 3 from both sides.
Subtract 3. So 2y equals negative 18. So what's y going to be?
Negative 9.
Negative 9. Okay. Huh? All right, so here's my question. We plugged that back in the first one. They always say you want to plug in the bottom one. What if I go in the bottom one? What's 1 minus 2y equals 19? What do I get if I subtract 1 from both sides?
Negative 18.
Positive 18, right? So now what's negative? I want to divide by negative 2. What's 18 divided by negative 2? Negative 9. So does that indicate that it doesn't matter which one you plug back into? And my hope is that you realize, hey, there's a built-in way for me to check to make sure I've done this correctly. If I want to plug back into the first equation, get some value back, and I get a number like negative 9 back, if my x was correct, then I should be able to plug into the other equation and also get negative 9 back. Does that make sense? If my x was 2, think about this. If my x was 2, and I thought that was the answer, I plug into here, and I find what y is when x is 2. It's not going to be the same answer when I plug x to be 2 in here. Does that make sense? Okay? That is the one and only one value that is going to make both of those evaluate to the same number. In this case, that number being negative 9. So just be on the lookout for that. If you want to check yourself, which I think we should, that's an option. You guys remember... Never mind. The calculator. I was thinking that we could use our calculator to help evaluate, but it won't. The way I'm thinking about it, it won't do that. Okay, so what I want to do here real quick, I want to make this, I want to change this equation real quick. So we're going to change this number right here to a, so let's go ahead and keep it here then. So you say multiply bottom one by 3, right? Why are you going to do that? Okay, so it's going to turn into... So he's seeing that that's 15, and that's negative 5, right? And they have a relationship to one another, right? 15 is a multiple of 5. So if I multiply 5 by 3, that turns into 15, right? So that's why he chose 3.
Yeah.
Say it again. I always add. You can subtract if you want, but the reason I don't subtract, and that's the idea, is that, remember yesterday we talked about how we're adding the same thing to both sides. When we add straight down, I'm adding 7x minus 5y to this side, right? And I'm also adding 17 to that side, but because 7x minus 5y and 17 are said to be the same, I'm really adding the same thing to both sides, right? So if we add the same thing to both sides, we should be able to subtract the same thing from both sides. So you can subtract here. You put a minus sign, go negative 2x minus 7x. Here's where people struggle. Negative 2 minus 7, or maybe sometimes it's like negative 2 minus negative 7, and subtracting negatives and stuff like that confuses people. So I always keep it as adding, and I look for coefficients that are opposite. If you're going to subtract, you'd be looking for coefficients that are the same. That make sense? But you can do it either way. And that's what I said at the beginning when I handed this out. I think it's typed up at the top. That the approach that I show you is just one of many different routes we could go. And usually you start to talk about and investigate those other routes, maybe in Algebra 2, College Algebra. We talk about different techniques that free up some time. If I multiply, so I'm multiplying by 3 here. It's going to be 21x, negative 15y, and 51. Does that make sense? Okay. So when I add straight down, so negative 2x plus 15y equals negative 32, doesn't change. I have 21x minus 15y equals 51. Like I said, I'm always going to add straight down. So what's negative 2x plus 21x? 19x. Hopefully you see here the purpose of why we multiplied by 3 then, because those are opposites. What does negative 32 plus 51 turn into? 19. So again, x is 1. Now we're getting 1 to be the answer here a lot, but that's not, it's just a coincidence. So if x is 1, can I come back up here and say negative 2 times 1 plus 15y equals negative 32? And now if I add 2 to both sides, it gives me 15y equals negative 30. And what would y be? Y is negative 2. So x is 1, y, that's a negative sign, negative 2. Yes?
I would know once you should be 3, like, that's 15 by 8, how do you get 15?
This number is allowed to be anything that it wants to be, or that we want it to be. If I want to multiply by 10, I could. But if I multiply everything by 10, nothing. I get 70x and I get 50x, right? Well, those aren't opposites of those two numbers. So we're looking. Let's look at this one here. We're looking for either the green numbers to be opposites or the blue numbers to be opposites, right? Does that make sense? Now, in this case, that doesn't happen right away. So the question is, what can I multiply 3 by in the top one to get this 4? Or what can I multiply 4 by to get that 3? Does that make sense? Or here, what can I multiply 2 by to get that 3? Or this 3 by to get that 2? Okay? Well, in this case, because there's not a whole number that I can use fractions, but fractions are a pain in the butt. So there's not a whole number I can do that with. But let's kind of finish that discussion real quick. Let's come back up here. If we start from scratch, then the question is, okay, now the reason Travis told us to cancel these is because he recognized that 15 is a multiple of 5, right? So he's able to make that negative 5 through multiplication turn into 15. So that's why he chose 3. Does that make sense? Because that's what you need to multiply to make it 15. Now here's the question. Let's say I wanted to multiply. So we knew the answer there. What do we have? 1, negative 2? Yeah. So let's do this probably a second way and see if we still get 1, negative 2. And maybe that'll prove a point to us to do that next question. Let's say we want to cancel the x's. Do you know a number? Now, a whole number or an integer. Okay, so no fraction, no decimal. Do you know a number you can multiply 2 by to get 7? Okay, but that's not a whole number, right? That's got a decimal to it. You could do that, but then 15 times 3.5 and negative 32 times 3.5, those are probably going to be ugly products. Okay? So I don't know a number that I can multiply 2 by to get 7, and I don't know a number I can multiply 7 by to get 2. Does that make sense? Yeah. Okay? Now, if I brought fractions in, fractions would be fine, fractions would work, but everything else turns into a fraction, and that's ugly. But is there a number, and think about the smallest number, that you can make both of those numbers, 2 and 7, grow to through multiplication? 14 will be the first number that those two things can turn into, right? So what we talk about 14 being a least common multiple, an LCM. Least meaning smallest, right? Okay. Multiple being we've multiplied. Okay. So it's the smallest number that we can multiply 2 and 7 by something to generate. So we're going to multiply 2 by to get 14. 7, right? Well, they're already opposites, correct? In terms of their sign. This one's already negative, this one's already positive. So if I multiply this one by 7, well, I have to multiply this one down here by to get multiplied by 2, right? Do you see how multiplying this top one by the bottom's coefficient and then multiplying the bottom one by the top's coefficient? Does that make sense? Okay. And then I'm just going to pay attention. Will this product make my x's opposite values, one being positive, one being negative? And it will. So When I distribute that 7, it's going to be negative 14x plus 105y equals negative 2, I believe it's negative 224.
Why did you exaggerate that whole, like?
How'd
you get 105?
Because 7 times 15. So I have to take 7 times all those things. And then we'll do the same thing down here in the bottom. So I get 14x minus 10y equals 34, right? Now if I add straight down, what's going to happen to your x's? They go away. How many y's do you have? 95 y's. This is going to go to 190. Okay, now it's going to be negative, right? So when I divide both sides by 95, I get y to be negative 2. Is that the same y value that we got the first round? Yes. Now plug that back in. I'm going to plug back in. I can plug back into any equation I want. We've got 4 total equations up there, right? But the 2 red ones or maroon ones are bigger versions of the 2 that we started with, correct? So never plug back into those. Always go back to the beginning. Go back to the 2 at the beginning. If I plug in y to be 2, which one of these makes more sense to plug y into? Bottom. So we're going to 7 be negative 5 times negative 2 equals 17. What's negative 5 times negative 2? We get that, right? So now 7x will equal 7. So what is that? 1. Is that the same ordered pair? So does that demonstrate 2 things? Doesn't matter which variable you cancel, right? Still get the same answer. And it demonstrates the idea if I do choose to cancel my x's, there's not a whole number that I can change that one into, or I can multiply 7 by to get 2, or a whole number I multiply 2 by to get 7. Then I'm essentially going to look for that LCM, the least common multiple.
That's what I was thinking for the next one here, because I was just like 12.
Okay, so the next one, it makes most sense. You're going to cancel what variable?
What?
What are you going to cancel? What variable are you going to cancel? X's or Y's here? You want to cancel the Y's? So you're going to say you want to change them to 12? Okay, so here it makes sense to change them both to 6. Does that make sense? Now, are you wrong by changing them to 12? Can I make that one go to 12?
Yeah, but
Can I make that one go to 12?
bigger step.
And that's the thing, is that now this number here, if I make that 2 go to 12, this would be an 18, right?
Oh, yeah.
And if I make that go to 12, this would be 16.
Yeah.
If I make this go to 6, that's going to be 9, and this is going to be 12. It's a little bit easier, right?
Yeah.
So if I can find that LCM, that's going to be the best thing to try to change both coefficients to. But once you find your LCM, any multiple of your LCM would also work. So you said the LCM was 6, so 12 would work, 18 would work, 24 would work, 600 would work. Okay.
Wait, was that multiply one by a negative?
Yeah. So here's the idea. If I've got, if you told me you wanted to cancel the Y's.
Yeah.
So what I'm going to do, we want to cancel the Y's, and this is something I think is very important for us to realize that we can do. I'm going to multiply this top one by that number right there.
Wait a second. Why?
Because if these got to go to 6, and one of them's 2, yep, and I'll multiply the bottom one by the coefficient that is blue there. Excuse me. So I got that. So, but now if I use 3 and 2, they're both going to be positive, right? So I'm going to make this one negative 2. And that will give me 9x plus 6y equals 3. And this one's going to be negative 8x minus 6y equals 4, right? Add straight down. 1x. And that will give me 7, right?
Oh, yeah. Why
Okay, so you're on the, because you're thinking if I would have left it as 3x plus 2y equals 1, and, I guess, sorry, let's write it as 9x plus 6y equals 3. So distribute that. But now if I distribute a positive 2 here, it would have given me 8x plus 6y equals negative 4, right? And now you're saying, well, subtract them, correct? What's 9x minus 8x? 1x. What's 6y minus positive 6y? 0. Now here's why I like to add instead of subtracting. What's 3 minus negative 4? 7. So does that demonstrate that it doesn't matter whether you add or subtract? But if you're going to add, you want your coefficients to be opposites, right? And that's what we're seeing right here, is that they were opposites. Okay? If I'm going to subtract, I want the coefficients to be the same. Because subtraction, by definition, is adding the opposite, right? So that's why I always look for opposites and I can add them. I like to add better. I think that's easier. Yeah.
Like, I think it's kind of like the second one or this one. Like, what would you multiply? Because then you have to multiply because these are both positives, they're not opposite.
Does the question say which variable we want to cancel or anything? So I would. Okay, no, just back it over. So I would, because they're already both the same coefficient, right? So I would just multiply the bottom one by a negative 1.
So you just not just the bottom one?
Yep, because that will make my y's negative, right? 1 would be positive 2y, and then it will be negative 2y, right? And those will cancel out, and I can have my x's and my constant. Yes?
Will we have time to ask my question?
We should, yes. Yes. So now if I've got x equals 7, can I plug that back in? So I'm going to plug it back into the first one, so I get 3 times 7 will be 21, plus 2y equals 1. So 2y would be negative 20, and y would be negative 10, right? So 7, negative 10 is my answer. Is that all right? What if I get, so I'm going to go down one more. Let's do this one real quick. What variable do you want to cancel? Actually, let me see. Let's not do this one. Let's. If I wanted to cancel the y's, what would you change them both to? 12. Let's do this. Let's go 6x plus 4y equals 12, and let's go 7x plus 6y equals 10, something like that. Okay. Now I don't want to go through because I just made random numbers up here, so the order pairs might be ugly here. But let's just go ahead and talk about which variables you want to cancel.
Y. Okay,
you want to cancel y's. So what's the least common multiple that you would use? 12. You can make both 4 and 6 go to 12, right? Now, would 24 be wrong? No, it's just not the least value, right? But I can multiply that one, and this is the idea of, if I want to cancel my y's, multiply the bottom one by the top one's coefficient for y, and multiply the top one by the bottom one's coefficient for y, and they both go 24, right?
So the top one would be 2, the bottom would be 3. Or is this opposite?
You'd multiply, so if I'd multiply the top one by 3, right? And the bottom one by 2? You wanted this to go 12y, right? You wanted these to go to 12y?
Yeah.
So how do I make 4 go to 12?
3.
Multiply by 3. How do I make 6 go to 12?
2.
Multiply by 2.
Oh, so it's just okay, I get it now.
What would be the least common multiple for canceling the x's? 42. So what would I have to multiply the top one by? 7. And what would I have to multiply the bottom one by? 6. Okay. Does everybody see that relationship between your coefficients and that least common multiple, or just in general a common multiple? Okay. If you are a person that's perfectly fine with working with bigger coefficients and bigger constants, if I want to cancel y's or I want to cancel x's, a lot of times people just say, I want to cancel x's and that's what I'm going to worry about. And they look and say, okay, well, if I've got, maybe, let's say we've got like 13x plus 4y equals 12, and then we've got maybe 4x minus 2y equals 10, okay? My hope is that you see that the y's would be the easiest to cancel, right? Does that make sense? I can multiply the bottom one by 2 and the y's cancel. But if I multiply the top one by 4 and multiply the bottom one by 13, one of them being negative, does that get my x's to cancel?
Yes.
Does that make sense? So inside the structure, there's information that you can use as your multiples or as your multiplier. No. Let's look at this one. What variable do you want to cancel? X? So what am I going to multiply by to get them to cancel? Negative 2. So if I multiply by negative 2, it's going to turn into negative 2x minus 6y equals negative 18. Now, okay, that's why this is a special case.
Oh my gosh, Timmy, what is that thing?
All right, so when we add straight down, those go to 0 and those go to 0, right? Now what's 0 plus 0? 0. You got your equal sign, right? And those go to 0. Remember seeing something like that a couple days ago?
That's no solution. No solution.
No, it's infinity.
What kind of answer is it? What will your answer to this be? Will this be a true or false statement?
No, because it's infinity.
True. And then a true statement leads us to infinite solutions. Okay? You guys know that's your symbol for infinity, right? Okay.
It's a sideways 8.
It's a limnason.
Yes, sir.
It is. I get this way. I swear I got it.
Okay.
But I'm doing the exact same thing on the board.
Yeah.
Let me finish this last one. I'll get you.
Oh, we have another one?
This is the last one.
Where's it at?
Okay?
We have
Yeah,
two
and
more.
then
Now what variable you want to cancel out? What variable?
variable. No.
X? So what do I need to multiply the bottom one by so that happens?
Positive 2. No, positive 1. No, positive 2. Multiply by 1. No, it is 1.
If I multiply by 1, it doesn't change.
Negative 1.
Multiply by negative 1. So that will turn into a positive number. This will be a negative number. And that will be a negative number, right? Okay. So now when I add straight down, what happens to my x's? They cancel, so that gives me 0. What happens here? 0, so it's 0 plus 0. 0, what's this going to give me? Negative 5. 0 does not equal negative 5, so that would be false. And when we have a false statement, that lends us to no solutions.
No, you said
Okay? Now, no solutions means the lines do not cross, right? So the lines would be parallel here, right? If we put those in y equals mx plus b form, the slopes would be identical. Okay? Something to help you, because I obviously that's not hard work to do that stuff, right? That adding and seeing 0 and stuff. But what do you recognize right now about those two things?
They're exactly the same.
They're exactly the same, and those two things are different. So when the left-hand side is exactly the same and the right-hand side is different, you're going to end up with something like 0 equals some other number other than 0, and that's always going to be a no solution. Okay? What about these two at the beginning up here? I guess it wasn't at the beginning, but if I multiply this one by 2, I get 2, this turns into 6, and this turns into 18, right? What do you now notice about the left-hand side? They're the same. What do you notice about the right-hand side? They're the same. So the lines would be overlapping each other, right? So they're always the same, always intersecting, so they're infinite solutions. Now what's your question?
I've tried to solve it like 4 times. Hey, I got these in 2 different times. I can't figure out what.
3x minus 4y equals negative 16, 4x plus 7y equals negative 9. So,
I thought you would multiply by 3 on top.
okay, so that's going to give you
I got 9x.
minus 12y equals negative 48. Yep. So what are you going to multiply the bottom one by then?
no.
So what was your goal to to cancel things here, what variable were you going to try to cancel? The x's?
Yeah.
So when you change this to 9, you multiply this by 3, you get 9.
Yep.
Do you know a number that you multiply 4 by to make that 9? The number that I want to change these both to is that product of 3 and 4. So I want to make 3 go to 12, and I want to make 4 go to 12. Is that what you did next one?
I did it on this one, and then
Okay.
I thought it was wrong, so I did it different.
Okay, so let me see. So you got 4, so it turns into 12x minus, there's the issue. So you got minus 4y here, right?
Yeah.
When you multiplied, you change it to a plus 16y. It should be negative 16y. Negative 64, you got 12x.
That's the bottom part.
Okay, so that should be 12x, and 3 times 7 gives me 21y, so that should be a positive 21y. Equals then negative 27. So the only thing that's going to happen here is you've got, so this should have been a negative number and this should have been a positive number. So your end result here where this is, and you added both those numbers. So but a negative 16 and a positive 21 are going to actually be 5 instead of 37. You just added the numbers there, right? You got to use their signs. But if you did this right, you get negative 5y, but you should get, because the signs need to be a negative and a positive there, you should get negative 5y.
Negative 5y. And
negative 5y, and then you're going to add those two together. That's right.
negative 5.
I would question, just give me, somebody turn my mic off and